In this video, we are going to be learning how to test for lead ion. As we can see here, we have some reagents that we're going to be using. We have sodium hydroxide solution, aqueous ammonia, potassium iodide, potassium iodine, potassium dichromate, and dilute hydrochloric acid. So, I if you're joining us for the first time, I want to encourage you to subscribe and then and also share and like. So what we're going to do here, well, as we do this live practical now, after doing the pre-lab practical, I'm going to be giving you another video clip that will help you understand how you can, the possible methods of seeing this kind of thing in exam hall. So that whenever you see something like that, you will not be, um, you will not be shaking, you will not be scared, because some people, when they once they hear quantitative analysis, chemistry practical, sort analysis, their mind will just be flying. But one thing about this analysis is just that for you to be successful in quantitative analysis or sort analysis, it's important you know some of the basic things about it. One, chemical reactions. We also know um, how to test those things, like identify how to identify the ions itself, how to identify the ions, and also what happens, the kind of precipitate that each of them produce. For example, I'm going to show you the kind of precipitate you will expect whenever lead ion is present in any solution, or a compound. When you dissolve a compound in in water, you'll be able to find out if this is lead, actually, if lead is present. So let's quickly dive into it. We have all these reagents here. The first thing we're going to do now is to test with sodium hydroxide. We're testing for with sodium hydroxide. Now we have a solution of lead here. This is a solution of lead. We pour it over into another test tube. So what we do here is, with the sodium hydroxide, we put few drops of the sodium hydroxide. We add just a small quantity of it. You can see we have a white precipitate. This white precipitate does not necessarily mean it's lead ion. This white precipitate can mean that is calcium, because calcium ion also give us white precipitate. Another this thing that give us white precipitate is what aluminium give gelatinous precipitate. The same thing with zinc. But then in this case, um, with this kind of precipitate, this heavy precipitate we have here is telling us that what we have here is likely to be, that is, if you're going to put your inference, if you're going to put your inference in an unknown substance, your compound you're testing, then in your inference now, what's supposed to be there is what, calcium ion or lead ion. So you can see that. So let's try in excess to know what we get if we add excess of sodium hydroxide solution. I want to encourage you to pay attention and watch this to the end, so that you'll be able to know what it's all about. You will never have problem again in identifying lead ion. So now we have a little quantity of it. We add sodium hydroxide in excess. Okay, and this one will be okay. All right. Notice now is soluble. Is soluble in excess sodium hydroxide. Now, for the fact that it's soluble, means that we are likely to have sodium. Sorry, we're likely to have lead ion or calcium ion. So now the next one we're going to be testing is what, with aqueous ammonia. With aqueous ammonia, let's see what we are likely to get with aqueous ammonia. Now we add the solution of lead ion. then aqueous ammonia in drops. See, we have a precipitate again. We have a precipitate. This precipitate we have, let's see what we have in excess when we add excess of it. Excess of aqueous ammonia to it. Oh, this thing is okay. Let me get some more. Let me get some more. So, um, this our this is our lead ion solution. We add aqueous ammonia more. Notice that the precipitate remains. That means it's insoluble. It's insoluble, which means um, we have some substance, some ion that can do this. Lead ion can do it, and like we, like I told you earlier on, lead ion can do that, and then aluminum will give us gelatinous precipitate. If aluminum, because we don't have gelatinous precipitate here, aluminum is not likely to be here. And then zinc is always soluble, so zinc is not also here. But in some cases where we have something like this, which is soluble, um, then we can also go down to test to know exactly what we have here. We know exactly what we have here. This one is telling us that what it's telling us now is that we don't have a million because it's not gelatinous precipitate, and then we have what lead present here. So the next thing we're going to be doing here is to really find out, if we are to find out exactly what we have here, let's try it with potassium iodide. With potassium iodide, it has another predetermined test for lead ion. So this is our lead ion solution. So we add potassium iodide, potassium dichromate. This is potassium dichromate. So on when we add it here, we have yellow precipitate. This yellow precipitate uh, indicates the presence of what lead ion. Lead ion always give us um, yellow precipitate with what potassium dichromate solution. The same thing is what you also experience when you add potassium iodide. So let's see do the same thing with potassium iodide. This is potassium iodide. We have our lead ion. Okay, so this is our lead ion. We add potassium iodide. This is potassium iodide. Add into lead ion solution. We still have the same thing. These two things, these two uh, um, tests with these two reagents is one of the major methods of identifying lead ion. Note very well, look at the color, it's giving us what um, yellow precipitates of what this is yellow precipitate of lead iodide. The other yellow precipitate we have is yellow precipitate of lead dichromate. So in this case now, this is one of the this is the test that you will also have in mind whenever you're doing tests for what lead ion. So the last one we're going to be doing is to test with um, dilute hydrochloric acid. Now, one thing you should note here is that all lead ion forms white precipitate with all chlorides, any chloride compounds, soluble chlorides. For example, hydrochloric acid, any chloride, sodium chloride, potassium chloride will always give you a white precipitate with lead. Now, this precipitate that you will have will dissolve in when heated. When you heat it, it will dissolve, and when it's cold, it will reappear again. So that's what we're going to do now to you know to show you another method of identifying this very ion. So if we have our lead here, then we add hydrochloric acid. We add hydrochloric acid to it. Notice the white precipitate. This is white precipitate that is formed. Now this white precipitate, when we heat it, we're going to be heating it right away. We're going to be heating it. Okay. So I'm heating it now. As I'm heating it, it's turning to clear solution gradually. Now it's dissolving gradually. It's dissolving. It's dissolving. Let's keep it. see it's somehow becoming clearer, clearer, clearer. But I don't think I will continue in beating this to that level because of the time of the video. What I will do now is to let you know that this thing is actually to actually dissolve now. What I will do is to allow it to go. When I allow it to go, the this thing will be more. It will appear more. Look at it. It's clearing. It's dissolving gradually. But I won't continue in this heating because of the time. So let me try to cool it with some. Let me allow it to cool small so that we'll see exactly what is going on. I see more crystals are forming inside it. They've been dropping. Let me remove this and burn it and heat it well so that we'll see very clearly. Okay. I have to increase the water, the water in it too, because it seems that the thing uh, initially it was saturated solution. That's why it could not really dissolve very well. I added more water to it. This is the this thing, the substance. It's actually dissolving now. What happened initially that why that thing could not dissolve very well then was because it was saturated. Now because I added more water here, the thing is actually dissolving completely. So this is one of the um, methods of identifying lead ion. How you can identify lead ion in a solution. Now we have a very clear solution. Now look at what will happen when we allow it to cool. As it's cooling, the let me cool it inside here. The crystal has reappeared, I think. Um, and allowing it to cool, this thing is coming back again. The precipitate is coming back. So when we heat again, it will also dissolve. As you can see, this is one thing that happened now. One thing is too peculiar with, is very peculiar with potassium lead ions. The two ions, that is what they do when you heat it. If we are to heat it again, I don't want to extend this really this week for too long. It has actually gone beyond what I normally allow. So you can see that it has appeared again. So when we heat again, it will come back again. This is one of the tests. This is how you can test for um, lead ion. Lead gives you white precipitate with sodium hydroxide, which is soluble in excess, insoluble in drops, but soluble in excess. With aqueous ammonia, it gives you precipitate, which is insoluble in drops and also insoluble in excess. With potassium iodide, it gives you yellow precipitate, which confirms the presence of lead ion. With potassium dichromate, yellow precipitate. With potassium iodide, the same yellow precipitate. That these are the things that confirm the presence of what lead ion. With dilute hydrochloric acid, what you will get there is what white precipitate, which is soluble when hot. When you heat it, it will be soluble. When it's cold, the precipitate will appear, where the white crystals will also appear again. That's another way of testing for lead ion. Thank you so much for being part of this class. Um, if you have any question, you can leave it in the comment section, and then we'll attend to you. Don't forget to share, like the video so that it can get to other people. Thank you so much.